All right, after exploring the periodic table in last lesson, we're going to look at a few more trends from the periodic table. So the first trend we're going to look at is atomic radius. So by the end of this, we will be able to identify the atomic radii trend on the periodic table, rank atoms based on their atomic radius trend, and predict the atom's radius of an element, the atomic radius of an atom based on its location on the periodic table. Okay. So atomic radius is the distance from the center of the nucleus to the edge of the electron cloud, right? So if you look in this picture, this from the center to the outer edge is our atomic radius. And it is usually measured in picometers, which is really, 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 really small. And there are trends on the periodic table that help us kind of rank who has a bigger atomic radius. Excuse me. So in the group, right? So if we're talking about the columns or the groups of the periodic table, then it increases from top to bottom. So the smaller atomic radius is up here and the bigger atomic radius is down here. And that is because, right, as we go down the periodic table, we add more electrons, so we have more energy levels. So one of the actually cool things is if you label your periods 1, 2, 3, 4, that is actually how many energy shells we have. As we go across the period from left to right, from right to left, it increases. So the smaller atomic radius is here and the bigger atomic radius is here. And that's because as we it's because of the number of protons, essentially, right? So if I have an atom that has 50 protons and I have an atom that has 5 protons, the electrons are going to be pulled in closer to 50 protons than they are to 5. And that's just because of their attraction. So what I would do is on your periodic table, draw these arrows in red and label them. So I would draw this arrow across the top and say increasing atomic radius, right? And maybe even kind of model. So over there it's small, over here it's big. And then it's small up here and it's bigger down here, and also put increasing atomic radius. I wouldn't make them as big as they are on this picture because you're going to end up putting 3 total arrows on the top and 3 total arrows on the side for all of the trends that you're going to be looking at over the next couple lessons. So if I look at my examples, right, I know that going this way and going this way, they're increasing. So if I compare sodium and chlorine, who has the larger atomic radius? Well, small over here to big over here, so sodium is going to have the larger atomic radius. Bromine or iodine, so bromine is here, iodine is here, and we have smaller up here, bigger down here. So iodine is going to have the larger atomic radius. And then our last example is calcium and strontium, and that's the same pattern, smaller up here, bigger down here. So strontium will have the larger atomic radius.